Hello everyone. My name is Sachintya Mahabela and I am currently reading for the MSc in IT at SLIIT. So this is my second presentation prepared for the Wireless Network Technologies module. In this presentation, I will discuss modern wireless technologies from short-range communication to global connectivity systems and how these technologies are used in real-world applications. Now let's move on to the overview. So today, wireless communication is not just a convenience. It is a core part of modern digital infrastructure. Almost every system we use, from smartphones to industrial automation, depends on wireless communication. Different wireless technologies are designed for different purposes. Some are optimized for short distance communication with low power, while others are designed for long distance communication with high data capacity. So, in this presentation, I will explain these technologies step by step. Now, let's move on to the next slide. So, let's start with core short-range technologies. There are two, Bluetooth and Zigbee. So, Bluetooth is mainly used for short-range communication between personal devices. For an example, when you connect your wireless earbuds or transfer files between phones, Bluetooth is used. It operates 2.4 GHz frequency band and uses frequency hopping to reduce interference. Devices form small networks and one device controls the communication. Then the next one is Zigbee. The Zigbee is different. It is designed for low power and low data applications. Instead of focusing on speed, it focuses on reliability and energy efficiency. The key feature of Zigbee is mesh networking. This means devices can pass data through each other. So, even if one path fails, the data can take another path. For an example, in a smart home system, lights, sensors, and controllers can communicate through this Zigbee. It creates a stable and scalable network. Now let's move on to the next slide. Next, we look at light-based and advanced wireless technologies. So, the first one is Li-Fi, light fidelity. So, Li-Fi is an emerging technology that uses light instead of radio signals. So, data is transmitted by rapidly changing the intensity of LED light. This allows extremely high data speeds. Also, since light cannot pass through walls, it provides better security compared to traditional wireless communication. However, Li-Fi has a limitation. It requires a direct path between transmitter and receiver. If something blocks the light, communication can be interrupted. And the next one is modern cellular. So now modern cellular technologies like 4G and 5G are designed for wide area communication. They support high-speed internet, video streaming, and real-time communication. So technologies like MIMO allow multiple antennas to transmit data simultaneously for increasing speed and efficiency. And beamforming focuses signals directly toward users instead of broadcasting everywhere for improving performance. So these technologies are essential for mobile communication, smart cities, and future applications like autonomous vehicle. Now let's move on to the next slide. LoRa technology. Long range communication technologies, starting with LoRa. So, LoRa is designed for sending small amounts of data over very long distances using very little power. It uses a special modulation technique called chirp spread spectrum, which makes it very robust against noise and interference. LoRa operates in sub-gigahertz frequency bands, which allow signals to travel longer distances compared to higher frequencies. Devices send data to a central gateway, which then forwards it to servers. For an example, in agriculture, sensor placed in fields can send soil moisture data over several kilometers using LoRa because of its low power consumption. Devices can operate for years using small batteries. And then next technology type. LoRaWAN is the network protocol that manages LoRa communication. It defines how devices send data, how gateways receive it, and how servers process it. It uses stars of stars topology where multiple gateways can receive the same data and send it to a central server. This increases reliability and coverage. So LoRaWAN also supports different device classes based on how often they communicate. And some devices send data occasionally to save power, while others stay active continuously. So security is also important for this LoRaWAN. It uses AES encryption to protect data. So this technology is widely used in smart city systems such as smart parking, street lighting, and environmental monitoring. And let's move on to the next slide. RFID. Next one is RFID technology, which is used for identification and tracking. So RFID systems consist of tags, readers, and antennas. So the reader sends radio signals which activate the tag. The tag then responds with stored information. There are different types of RFID tags. So passive tags do not have batteries and rely on the reader's signal. And the active tags have their own power source and can transmit signals over longer distances. And RFID operates at different frequency ranges depending on the application. It is widely used in supply chain management, warehouse systems, and access control. For an example, Supermarkets use RFID to track products, and offices use RFID cards for entry systems. Right? Now let's move on to the next technology. NFC technology. So NFC is an advanced form of RFID designed for very short range communication. So it works when two devices are very close, typically within a few centimeters. For an example, when you tap your phone to make a payment, NFC is used. NFC operates 13.56 megahertz and uses electromagnetic induction for communication. One important advantage of NFC is security. Because the range is very short, it reduces the risk of unauthorized access. And NFC supports three modes. In reader or writer mode, a phone can read tags, and then peer-to-peer mode, two devices can exchange data. And the third one is card emulation mode. That is, a phone can act like a smart card. So this is why NFC is widely used in digital payments, transport cards, and secure access systems. Now let's move on to the next slide. IoT, the Internet of Things. So IoT is one of the most important concepts in modern wireless communication. So IoT refers to a network of physical devices that are connected to the internet and can collect and exchange data. So these devices include sensors, machines, appliances, and even vehicles. So the basic working process is simple. First, sensors collect data from the environment. Then this data is transmitted through a network to a gateway. Finally, that data is sent to cloud systems where it is analyzed and used for decision making. For an example, in a smart home, sensors can detect temperature or motion and automatically control devices like lights or air conditioning, right? And then IoT systems use different communication technologies such as Wi-Fi, Bluetooth, Zigbee, and LoRa depending on the requirement. The key idea is automation and real-time monitoring for IoT systems. And then next, technology. Wireless sensor networks. So, wireless sensor networks are closely related to IoT. So, WSN consists of many small sensor nodes that work together to monitor environmental conditions. Each node has a sensor, processor, communication unit, and power source. So these nodes communicate with each other and send data to a central base station. One important concept here is multi-hop communication. This means data can pass through multiple nodes before reaching the destination. This means data can pass through multiple nodes, right? So, this increases coverage and reliability. For an example, in environmental monitoring, sensors placed in a forest can collect temperature or humidity data and send it to a central system. WSNs are used in disaster management, agriculture, military applications, and industrial monitoring. Now let's move on to the next technology. Human-centric networks. There are two human-centric networks, body area networks and vehicle area networks. So the first one is body area network. So body area networks are used for communication between devices placed on or inside the human body. These devices include wearable sensors, smartwatches, and medical implants. They collect important psychological data such as heart rate, temperature, or movement. Then this data is transmitted to a central device like a smartphone. The communication range is very short, usually within 1 to 2 meters. And power consumption is very low. For an example, in healthcare, a patient's vital signs can be monitored continuously using body area network technology. This allows remote monitoring and early detection of health issues, right? Finally, let's move on to the vehicle area networks. These vehicle area networks that are used inside vehicles to connect different electronic systems. Modern vehicles have many sensors and control units that need to communicate in real time. For an example, systems like engine control, braking systems, airbags, and navigation all need to exchange data. So protocols such as CAN are used for this communication. So these networks ensure that all vehicle systems work together efficiently and safely. So vehicle area networks are also important for advanced systems like autonomous driving and driver assistance technologies. So this is the conclusion of my presentation. So in conclusion, modern wireless technologies cover a wide range of applications from simple short-range communication to large-scale global networks. Each technology is designed with specific goals such as speed, range, power efficiency, and reliability. Understanding these technologies is important for developing future systems such as smart cities, IoT environments, and advanced communication networks. So, thank you for your attention and have a nice day.